So hello guys, this is another question from IIT JEE PYQ. The question is from the Advanced 1985. Uh, the question is from the Advanced 1985. It is a simple question actually. What is the question? A uniform chain of length L and mass m is lying on a smooth table and one third of its part is hanging vertically down over the edge of the table. And g is the acceleration due to gravity. We have to tell work required to pull the hanging part on the table. Okay, so what is the scene here? This is our table, let us suppose, and this is our chain. Let us suppose this chain length is L and one third of its path is hanging in downward direction like this. Okay, this is the L by third part and the length of string is here, that is 2L by 3. Okay, so two-third of this part is on the table and one-third of the part is hanging in the downward direction, vertically downward. Okay, so if I suppose that total mass of this length is L and it is having a uniform mass distribution, then mass of this part, hanging part, will be equal to m by 3, right? And the position of center of mass for this hanging part will be equal to what? If I take this is our origin here, then this length will be equal to L by 6. Okay, so here is the situation. Here this hanging part, I can assume a point particle here. Now point mass, so this is our table here, and from this level of this table at a distance of L by 6 there is a point mass, and the value of this point mass, let me suppose it is equal to m by 3. Okay, and the acceleration due to gravity is acting in downward direction, right? Now we have to take this particle in this on this table, right? So let me suppose this is the reference level for the potential energy, reference level. Now work done by us, like work done in taking this particle, in taking this mass on the table, that will be equal to what? That will be equal to change in potential energy of this mass. That is equal to what? Change in potential energy of this mass. Potential energy of mass. Okay, so let me call this is our initial here, this is our initial point and this is our final point, and we are taking this particle, this point mass, from this initial point to the final point. Okay, so I will be writing here the potential energy of this mass at initial point, that is equal to what? If I am taking this table as the reference frame, then from this reference point the potential energy of this mass will be equal to negative of mg into this height from this the distance from this reference point. Okay, so this will be equal to, mass is given as m by 3, that negative sign, g into length will be equal to what? Height, that is L by 6. So it will be equal to negative of mg L by 18. Okay, now since we know that the final potential energy will be at reference point, that we are taking 0, so final potential energy will be equal to 0. Okay, so similarly we can write here change in potential energy is equal to U final minus U initial, that is equal to 0 minus negative of mg L by 18. Okay, so that is equal to what? Mg L by 18. So here work done will be equal to what? Work done will be equal to change in potential energy, that is equal to mg L by 18. So this is our answer. Let me check the option here. Here mg L by 18, that option D is correct.